So just to review, you guys, I put about I put 3 problems that involve law and division first, so then we can get to the dividing the polynomials here in a little bit. And so we start with this. I put my 3 on the outside. 3 goes into 981. Very important that you have your placeholders in the correct spot. So I first identified as 3 go into 9. How many times? That gives me 9. I subtract, and I get 0. What do I do then? Drop down my 8. Does it go into 8? Twice. I get 6. 2. Drop down my 1. 7. 327. That is the way I do long division. Is that confusing to anybody? So everybody can keep up with how we normally do long division. That will help you as you then see polynomials involving long division. So I try the next one. 15 goes into 15,675. And I start by asking, does 15 go into 1? No. Does it go into 15? How many times? So since it goes into 15, I put the 1 over the 5. Goes in there once, I get 15. Subtract, I get 0. I drop my 6. Does 15 go into 6? So what do? Put a 0. It went into that 0 times, so I have to do that. Now I can drop down the 7. Does it go into 67? 4 times, which gives me 60. Subtract, and I get 7. Drop down my 5. Does it go into 75? 5 times. Leaves me with 75. I get 0 as a remainder, 1,045. So very important that you put the 0 there. A lot of people forget that, especially when we're dealing with polynomials in particular. The placeholders will be extremely, extremely important for us. Last one, 1,024 divided by 7. 7 goes into 1,024. 7 go into 1. How about 10? Goes in once. Subtract, I get 3. Drop my 2. How many times does it go in 32? 4, which is 28. How about 44? 6 times. 42, which is a remainder of 2. Now, the way that you often write is with a remainder of 2. And it looks like your book even addresses it this way. I don't accept this. We need to move a little bit further. So I will challenge you here that one way to write 146 with a remainder of 2, there's 2 different ways to write it. One, you can write it like this. 146 and 2/7, right? Or 146 plus 2/7. And that second way is what I want you to keep in mind, because when we get to dividing polynomials, that's going to come in handy. So notice that the 7 is my divisor, the 2 is my remainder, and that's where I get those pieces. Let's transfer now to polynomials. To divide polynomials, we have x plus 2 in front, and I have 3x plus 6. I'm seeing if a binomial divides evenly into another binomial. And I always ask this question. Watch this very carefully. I look at my first term, which is x. Does that go into 3x? How many times? 3. 3 is not a quadratic term. 3 is not a linear term. 3 is a constant term. So it goes above the other constant term. See how these are the same? They're both constant. Now you multiply back through, just like we did before. 3x plus 6, when you multiply it back through. Subtract them, and I get 0. So if you take x plus 2 and divide it into 3x plus 6, you get 3 as your result. So 3 is the answer. Let's try something slightly more difficult. X minus 1 divides into x squared minus 10x plus 9. Now I'm seeing if a binomial divides evenly into a trinomial. And I always start by asking, does the first term go into this first term? Does x go into x squared? How many times? X. Or the other way of asking it, what would you multiply x by to get x squared? We will multiply it by x. Is x quadratic, linear, or constant? Linear. So it goes above the other linear terms. I then take that factor of x, I multiply it through my divisor, which is x minus 1. I get x squared minus x. Now it's time to subtract those. Careful with your subtraction. I have x squared minus x squared, which gives me, it will always give you 0. If you ask what you multiply this term by to get that term, then they should always cancel, which is why it makes it possible. But now for the second part, I have a negative 10x minus a negative 1x. So it's a negative 10 plus a positive 1 then. So be very careful with your subtraction. I end up with a negative 9x. What do I do next? I have to bring down enough terms to make up a binomial. I do have a binomial. So if I didn't have anything there, I would have to bring down 2 terms. I need to make enough for a binomial, okay? All right, what do you multiply x by to get negative 9? I'm sorry, what do you multiply x by to get negative 9x? Negative 9. That is a constant. It goes above my other constant. I multiply the negative 9 back through. I get negative 9x plus 9, subtract 0. So if you were to divide those, you would get x minus 9. That is my answer. I know I've said it a few times. I just want you to make sure you see it again. Do you see how those line up? Do you see how these line up? That has to happen every time. Otherwise, you will begin to make mistakes. Any questions on example A or B? Going once, twice, thrice. Okay, we'll try C and D using long division, and then I will show you what is infinitely easier, which is synthetic division. Now for C, we need to be careful. I write my x minus 2, but do you know what goes underneath there? X to the third plus 0x squared minus 6x plus the 4. It's very important that when you have your binomials or your polynomials that we account for any terms that are 0, because they are really placeholders. Think of the number 1045. If you just wrote it as 145, that would be much different in value. Same way is true here when we end up dividing it. We need to make sure that we have those proper place values. So I have a binomial going into a 4-term polynomial. What do you multiply x by to get x to the third? X squared, so that goes above my x squared term. Multiply back through, get x to the third minus 2x squared. I subtract those pieces. What do I get? Positive 2x squared. 0 minus a negative 2. What do I do? Drop down enough to make a binomial. What do you multiply x by to get 2x squared? Positive 2x. Multiply the 2x back through. 2x squared minus 4x. Subtract them. What is negative 6 minus a negative 4? Negative 2x. Drop down my 4 to create another binomial. What do you multiply x by? Get negative 2. X multiplied by negative 2. Multiply it through, we get negative 2x plus 4. Subtract, we get 0. So you can see my answer, x squared plus 2x minus 2. And again, please notice that the squared terms are lined up, the x terms are lined up, and the constant terms are lined up. So quadratic, linear, and constant terms are in order, which is very important. We haven't had a remainder yet. We will get a remainder on the next one. X plus 7, 3x squared plus 4x minus 2. What do you multiply x by to get 3x squared? 3x. I'm left with 3x squared plus 21x. I subtract. Negative 17x. Drop down my minus 2. Multiply by negative 17. So negative 17x minus 119. If I subtract those, I get a positive 117. Now, here's where I want you to make a note probably differently than what your book does. And the reason why is because I feel that this is more, anybody can write remainder 117. I want you to think of it in terms of a polynomial, and the way that we would have to write it is the way that we would actually see it graphed would be as follows. 3x minus 17, and then like we did above, we have our remainder over our divisor. Do you see this? Our remainder of 2 over our divisor 7. So I'm going to write this as plus 117 over, what is my divisor? X plus 7. That's the way you write a remainder. Yeah? Coming back to you? All right, for the last two, I'll show you synthetic division, which again is incredibly easier. And I'm going to use plenty of space. For synthetic division, we start with our root. And when I say root, I'm referring to the root of the divisor. If you look at x plus 3, what is the root or the 0 of x plus 3? Not x, but what's the number that you plug in to get 0? Negative 3. That's the number you put in there. The root of the divisor. Up top here, you put your coefficients. What are the coefficients of my polynomial? Don't forget the 0x. And the last column is reserved for the remainder. The remainder will pop up there. So organizing it is the first step. Now, we did this last year, right? But you maybe don't remember the process. Here's all we do. We take the first term, the first coefficient, we drop it. 2. After that, everything's the same. We multiply and add, multiply and add, multiply and add. Negative 3 times 2. Add. Negative 5. Multiply. Negative 3 times negative 5. Add. Negative 3 times 15. Negative 45. Add. Negative 47. That last one represents my remainder. You don't have to put that box there. You could just remember. I do it because I think it's helpful. The one next to the remainder is my constant. The one next to that is my linear term. The one next to that is my quadratic term. What do these numbers represent? The coefficients, very good. So 2x squared minus 5x plus 15 minus 47 over x plus 3. Was that? Cover it up. You would get a 0, and you just wouldn't write anything. No problems. So if you get a 0 there, then you realize that it divided evenly. You got no remainder. Easier or harder? Is it coming back to you? So Kim, Levi, Tyler, Jed, it's been 2 years since you've seen that, right? Kind of remember it? Let's try another one. Then you guys could get started on your assignment. You're going to have a lot of work time today. My second hour class, they're an excellent class. Very, very sharp, bright group of students. But there's a lot more of them. There's about 30 kids in that class. And it takes us generally about 10 minutes longer to get through the lesson. Probably because it's my first time teaching it. And there's more questions. And it takes a little while longer. You guys always have a little bit more work time. Okay, so you tell me how to set this one up. What goes up here? 5. How about across here? So the 0 for my x to the third, the 0 for my x. Remainder at the end. I drop the 1. And I multiply. 5 times 1. 5. Add, I get 5. 5 times 5 is 25. Add, I get 21. Multiply, I get 105. Add, I get 105. Multiply, I get 525. Add, I get 527. So we've just taken a long division problem, and we've done it in just a matter of seconds. And again, the 527 represents my remainder, 105 my constant coefficient, 21 is my linear coefficient, the 5 is my quadratic, and the 1 is my cubic coefficient. So my end result, x to the third plus 5x squared plus 21x plus 105 plus 527, whoop, divided by my remainder of x minus 5. Yeah? Question. You are correct. Yep. No. No. Okay. Whitney brings up a very good point. I want everybody to understand that. She is right 95% of the time. She says, okay, we have x to the fourth, so our new results could be x to the third. That's if we're dividing by a linear term. So we're dividing by x plus x minus 5. What if we were dividing by x squared minus 5? Then we would end up with a quadratic result, right? Because a quartic divided by a quadratic would be quadratic. So just one thing, please note this type of a problem. If you had a trinomial like number 5, people got confused where to start here. I do the same process, but I ask myself, what do I multiply x squared by to get x to the third? I multiply it by x, and the x sits over the x, the linear term. If you take a cubic and divide it by a quadratic, what are you going to get? Linear, x to the first power. That's your assignment. Page 278, 1 through 7 odd, 11 through 19 all. The first 4 are long division. The next 9 are synthetic division. You may get it done before the hour is over because you are super smart.